Well, let me explain something cool to you guys. So, in this one, we are going to explain how uh, computers think and do things like playing games or watch videos. So, well, sometimes those computers need help thinking, solving problems. That's where something called neural networks comes in. All right, so a neural network is like a super smart robot that can look at lots of information and figure out what's going on, and it is like a big team of tiny brain cells which are working together to solve problems. To make it work, we need to tell the robot some rules, like what to do when it sees something new, and that's where parameters come in. Think of parameters as special instructions that we tell that robot to think. So this is our robot, and these are our parameters. We are going to give these instructions to robot, which he will read, and he will know these things. So these are parameters. So we give those things to robot to let it know how to think. Then now let's talk about special kind of neural networks called multi-layer neural network. It is like having multiple layers of tiny brain cells working together. So it will look something like input, and then it will do something in these, and will not know what is going on in these things, and we are going to get some output here. So that's how it will look basically. So here's a cool thing: in between those two layers there is another layer. So this one, imagine this one as an input layer, and imagine this one as an output layer, and in between these two we have one hidden layer. So that's what we call hidden layer. It is like a secret agent which helps our robot. So this is our secret agent with this super cool hat. Alright, so this is our secret agent which we call as a hidden layer, which will help our robot to figure out how to think by looking at all the information in a new way. So to make it work, we need to tell the hidden layer some rules too. So we're going to give our agent some rules as well, and he will read those rules as well. So it will help the agent to figure out the hidden layer, to figure out what's going on. So when we put all things in the pieces together, we are going to get a neural network that can solve problems, and that's the best part. So we can write some super simple code to make it work. So let me show you example. Imagine we want to make a robot that can recognize pictures of cats and dogs. So to do this, we need to teach robot what features look for in those pictures, like eyes or fur. That's what we are going to call inputs, right? So then we are going to tell hidden layer some rules about how to combine these inputs together to figure out whether it's a cat or dog. That's what we call activation function, which we represent as a sigmoid function, which we will be having these things. And here's what code might be looking like. So uh, I'm going to explain the mathematical part behind it a little bit. So we are going to look into, so let's imagine these things as a x1, x2, x3, and we are going to call this layer as a zeroth layer, this layer as first, and this layer as a second layer. So these are our layers of the neural network. And how we represent each node of the neural network: we're going to represent the first node as a1, then the second node as a2 of the first layer, then third node as a3 of the first layer, then fourth node as A4 of the first layer. That's how we are going to explain the whole thing, right? So uh, A0 is going to be equal to X, and that's going to be our activation function, right? So values which neural network passing on to the subsequent layer are going to be looking like these things in the matrix form. Alright, so y hat is going to be equal to A, and now what will we be looking at is one cool equation which we all know from previous ones. So x1, x2, x3 is going to be giving us this thing, W transpose X plus B sigmoid Z, and what we're going to have this thing as Z and this thing as A. So how we are going to write those things is Z is equal to W transpose X plus B, and A is going to be sigmoid of Z. So that's how it will going to look like. So we are going to compute some basic things now, so don't worry, it will make sense. So x1, x2 and x3, combining these, we're going to have first layer of Z, W transpose of X plus B, and first layer of A is equal to sigmoid of Z, and the layer, so basically remember this thing is a layer, and this thing is a node in that layer. So basically how it will work as imagine these things again, imagine this as a node. So that's our equation for this. Imagine this as a first node, alright, and that's our equation for first node. And now we are going to calculate our equation. So basically this is the first part of the equation and this is the second part of the equation. So I'm hoping you guys are following with me. So the first part of the equation of the second node will look like Z1 of 2 W2 transpose X plus B2, and the second part will look like A2 of the first will equals to Z2 of the first layer, and that's how it will be looking like. So I'm hoping the concept is clear. So now what we're going to look at other super cool things. So we are going to look at so you guys can understand. So we are going to have 4 equations like these. So we are going to have, these are the first 2. Now we are going to have 2 more equations like these. Z3 is equal to W3 X plus B3, and we're going to have the similar thing with A3. So keep track of these notations, alright guys. So Z3 of 1, then we're going to have Z4 of the 1, which will equal to W4 of the 1 transpose of X plus B4, and then our a4 of the one is equals to z4 of the one. So now, as you guys can see, we can see all these w's, so I'm going to use some different color. So these, we can see these w's, so we are going to check these w's, and we're going to, can we use other color? That's awesome. Okay, so let's use this thing, and I will denoting z is equals to w 1 of g until w4 of g, like g means transpose, and we are going to, I'm going to write that, I'm not going to be lazy here. And now we're going to multiply, matrix multiply this thing with x1, x2, x3, and we're going to add b from these things. Alright, so as you guys can see, so we're going to add b 1, 2, 3, 4 into these matrices. Alright, so b that's how it will be basically, and it will give us output as w1, w2, w3, w4. This is the same thing, first layer of x. These things are x, b1, b2, b3, b4, again 1, and that will be equals to these z terms, like z1, z2, z3, z4 of the first layer. Alright, I'm hoping the concept is clear until now. So we're going to get the activation function a of the first layer. Let's change the color, let's go back to black so it is making sense more. So we're going to have a1 to a4 of first layer. This is square bracket, alright. It will equal to z of the first layer. So basically we're going to have these equations where we are going to calculate and write z of the first is equals to w of the first times x plus b, first node of b of the first layer, and we're going to have the dimensions as the 4:1 of this for this one, then 3 for this one, then 1 for this one, then 1 for this one, and we're going to write this one as well. Now this is going to be logistic regression for input layer. Alright, input layer, logistic regression for input layer. That's how it will look like. Now we're going to look at logistic regression for output layer. Right, so how it will look like, that's what we're going to see. So Z2 is going to be equals to W2 A1, sorry, I wrote it wrong, A1 plus B2, and the dimensions will be 1 1 for this thing, then 1 4 for this thing, and 4 1 for this thing, and 1 1 for this thing. And we are going to have the second layer here. The dimensions will be 1 1 for this thing, and our sigmoid thing, and Z second layer, and our dimensions will be looking like this. So this will be logistic regression for output layer. So I'm hoping these things are getting clear. So this is for input layer logistic regression, and this is for output layer. This is for output layer logistic regression. So I'm hoping these concepts are clear. And yeah, when you have to figure out neural networks one hidden layer, these are your go-to equations, 4 equations, one hidden layer. I'm hoping you guys are getting used to my abbreviations of the thing. So we are going to understand the Python script for the same thing. Alright, so let's write these things in the code. So z of 1 will be w of 1 times x plus b of 1, then a of 1 will be sigmoid z of 1, and where z of 1 is output of the hidden layer, a of 1 is the activation of the hidden layer which we use to make predictions, and y hat is going to be final prediction whether the whole thing is a cat or dog. So that's what we're going to write here. Z2 is going to be looking like W2 times Z1 plus B2, and y hat is going to be equals to a of 2. So yeah, that's the y hat, and that's our final thing which will predict the neural network, which if it is going to be giving us the output of if this thing is a bird or cat. I'm hoping neural network will understand my drawings. So yeah, that's it. We written some code to make a simple neural network work, but here's the best part. We can also write code to train this network on a lot of examples, so it gets better and better recognizing the pictures. So I'm hoping that is making sense. So we're going to dive deeper in these concepts in upcoming videos. Until then, keep grinding, keep learning, keep hustling. See you in the next one.